Hi everyone. Today we're going to talk about exponentials. What is an exponential expression? When you have a number like b, for example, and raise it to a power of another number like p, this is called an exponential expression. B is going to be the base and p the power. We're going to learn about some exponent rules first and use those rules to simplify expressions. And after that, we're going to learn about exponential graphs. So first of all, let's see how do we use the law of exponents to simplify expressions. So we're going to talk about some properties or some rules basically. The first property is power of 1. If you have a number raised to the power of 1, that's always equal to the base. For example, if I have 5 to the power of 1, it's always equal to 5. So basically, power of 1 doesn't change the exponential expression. It's always equal to the base. Next one is power of 0. If you have something to the power of 0, that's always equal to 1. For example, if I have 5 to the power of 0, it's equal to 1. And doesn't matter what is my base, it's always equal to 1 if it's raised to the power of 0. For example, 1298 to the power of 0 is 1. Whatever is number, anything to the power of 0 is always equal to 1. Negative power, if you have something, a number, raised to a negative power, what happens then? First of all, we need to know that usually we don't like power of negatives. It's easier for us to understand an exponential if it has a power of a positive number. So we are usually going to change exponentials to the power of negative numbers to something to a positive power. How do we do that? We just need to flip the base and opposite the sign of the exponent. So like if I have a, that's going to be 1 over a. And if I have a power of negative m, the sign of this negative m is going to be changed to the opposite, like it's going to be positive m. Let's do an example. If I have 4 to the power of negative 3. So to change this to a positive power, the first thing that I'm going to do is to flip the base. So this will be 1 over 4. And then the power will be a positive number. So instead of negative 3, I'm going to have positive 3. We know that if we have a fraction, then both top and the bottom of the fraction will be raised to the power. So this will be 1 to the 3 and 4 to the 3. We know that 1 to the power of anything is just 1. And then the bottom will be 4 to the power of 3. So basically what we did here is to flip the base and opposite the exponent. So it will be 1 over 4 to the 3. Let's do another example. What if I have a fraction like this? Let's say 4 over 5 to the power of negative 3. So all I need to do here is to flip the base, like 5 over 4. Instead of 4 over 5, I'm going to write 5 over 4, and then the power will be 3. What if I have something like this? Let's say 4 to the power of negative 3 over 5 to the power of negative 2. As you see, in this case, we have a fraction. Top and the bottom, each of them separately have a separate number with a power of negative. So we want to get rid of these negative signs. So all I need to do is to flip each of them. That means if I have a 4 on top, I'm going to flip that and move it to the bottom and then write it with a positive power. And this one, 5, is in the bottom. So I'm going to flip that and move it to the top. This will be 5. Now this time the power will be positive 2, not negative 2. So that's how we change the powers from negative to positive. Next property is power of a product. If you have two exponentials with the same base multiplied to each other, you're going to keep the base and then add the exponents. So here, keep the base, it will be a, and just add the exponents. It will be m plus n. Let's do an example. Let's say we have 4 to the power of 3 times 4 to the power of 2. 4 to the power of 3 is basically 4 multiplied by itself for 3 times. Oh, I'm sorry, this is 4. 4 multiplied by itself for 3 times. And then 4 to the power of 2 is 4 multiplied by itself for 2 times. So how many 4s do we have here? It's 1, 2, 3, 4, 5. So this will be equal to 4 to the power of 5. And if you notice, 5 is basically 3 plus 2. So I can say, instead of writing all of these, I'm just going to, if I have something like this, I'm going to keep the base as 4 and just add up the exponents. This was 2. And it will be 4 to the power of 3 plus 2 is 5. Let's do another example. If I have 5 to the power of 6 and 5 to the power of 9. Okay, now this time, instead of writing all these multiples, like multiply 5 6 times by itself and multiply 5 9 times by itself, I'm just going to keep the base and add up the exponents. 6 plus 9 is 15. So this will be my answer. Even if you have a negative amount of power, in this case, you can use it. Let's say, for example, we have 5 to the power of 6 times 5 to the power of negative 4. Again, I'm going to keep the base and add up the exponents. 6 and negative 4. 6 and my negative 4 will be 5 to the power of 2. That's the answer. So just add up the exponents. Next one is power of power. What if you have an exponential and raise it to the power of another number? In this case, you're just going to keep the base and multiply the exponents. So keep the base, which is a here, and multiply m by n. It will be a to the power of m times n. For example, I have 4 to the power of 3 to the power of 2. So here I have 4 to the 3 basically multiply by itself 2 times. So 4 to the 3 times 4 to the 3. This means 4 to the 3 to the power of 2. Then, what is 4 to the 3 itself? It's 4 multiplied by itself for 3 times. And the other one again is 4 multiplied by itself for 3 times. Now, how many 4s do I have? 6 of them. And if you notice, 6 is basically 3 times 2. So you just need to multiply the powers and get the answer. Another example, let's say I have 5 to the 2 to the power of 8. I just need to multiply the powers. So this will be 5 to the power of 2 times 8. It's 16. Next rule is power of exponent. If you are dividing two exponential expressions and the base of both of them are the same, you can just keep the base and subtract the exponents. For example, I have 5 to the power of 3 over 5 to the power of 2. What is 5 to the 3? This is 5 times 5 times 5. What is 5 to the power of 2? It's 5 times 5. Okay, so I can simplify these this expression, 5 by 5 will go away, and this 5 will go away by this one, and then we'll have only one 5 left here. So it will be equal to 5. Basically, it's to the power of 1, and 1 is 3 minus 2. So instead of doing all these evaluations, I'm just going to write that as 5 to the power of 3 minus 2, which is 5 to the power of 1. Let's do another example. Let's say I have 4 to the power of 18 over 4 to the power of 12. Instead of multiplying 18 times on top and 12 times on the bottom, I'm just going to keep the base and subtract the exponents. 18 minus 12 will be 4 to the power of 6. The last rule that we're going to learn is power of a fraction. That means if we have a power which is in fraction form. Always if we have, let's say for example, this example, 4 to the power of 5 over 3. The exponent here is a fraction. I'm going to change this to radical form. How do I do that? I'm going to keep the base, put the radical here. The top of the fraction is going to be the exponent of the base, and the bottom of the fraction is going to be the index of the radical. Like here, I'm going to write the radical and then write the base. Now, the top of the fraction, which is 5, is going to be the power of base. And the bottom of the fraction will be the index of the radical. So this will be third root of 4 to the power of 5. Okay, so let's use these rules that we just learned to simplify some exponential expressions. Okay, so let's start with this one. 4 to the power of 1 over 2. We just learned that if we have a power of a fraction, we can write this as radical form. So I'm going to keep the base, put the radical. Top of the fraction is 1, and the bottom of the fraction will be the index, goes here. Now, 4 to the power of 1 is 4, and we know that if we have a base of 2 for a radical, we don't have to write that. So this is just root of 4, and that's equal to 2. So we simplified this to 2. 4 to the power of negative 2. We learned that we don't like negative powers, so we want to change this to positive. So what I'm going to do here is to flip the base. 4 will be 1 over 4, and the power will be positive. So 1 over 4 to the 2. 4 to the 2 is 16. It's just 1 over 16. Next one here, we have 4 to the power of negative 1 over 2. So we have a power which is both negative and also a fraction. So the first thing that I'm going to do is, first of all, get rid of the negative. So this will be 1 over 4 to the power of 1 over 2. And then this 4 to the 1 over 2, I can write it as radical form, like what we just learned here. Root 4. And this will be 1 over 2. Next one is 4 to the power of 3 over 2. Again, the power or the exponent is a fraction. So this will be a radical form. Radical 4, the power of this 4 is going to be the top of the fraction. And the index of the radical will be the bottom of the fraction. So this will be the answer. I can simplify this. 4 to the 3 is 4 times 4 times 4. So if I have 2 4s here under the radical, which has the base of 2, I can take this out of the radical. So this will be just a 4 like these two 4s will step out as just 1 4. And then I will have 1 4 left inside. And we know that the second root of 4 is 2. So this is 2. And this is going to be 4 times 2, which is 8. Okay. Next, I have 4 to the negative 3 over 2 to negative 8. The first thing that I want to do here is get rid of the negatives. So this will be 2 to the 8, 4 to the 3. So all I did here is to flip the top, like move it to the bottom and write the power of positive 3. And then flip the 2 in the bottom, move it to the top and make the power as a positive number. Now I can simplify this. Let's keep the top as 2 to the 8 and the bottom 4 is basically 2 to the 2. And then I had another power of 3 over 4 on, basically the 4. So this is 4 to the power of 3. It will be 2 to the 2 to the power of 3. So top is 2 to the 8 and the bottom I have power of power. So I multiply the powers. This will be 2 to the power of 2 times 3 is 6. Now I'm going to keep the base and subtract the powers. 8 minus 6 will be 2 to the power of 2, which is equal to 4. Next one, 3 to negative 2 over 4. First, we want to get rid of this power of negative. So the fraction that I have, I'm going to keep that. And then the top, which has a power of negative, I'm going to move that to the bottom. So 3 to the power of 2. And the bottom, I had a 9. It has a power of 1, basically. So there's nothing that I want to change for this one. So I'm just going to keep that here. Now, what is left on top? It's basically 1. It's not nothing. It's 1. Because I flipped the 3. Flip form of 3 will be 1 over 3. So I have a 1 on top and the 3 goes down. Anyway, so this will be 1 over 3 to the power of 2 is 9 times 9 is 81. So it's 1 over 81. Now this one, we have 1 over 4 to the power of negative 2. We want to get rid of this negative 2. Just flip the base. The flip of 1 over 4 will be 4. And the power will change to a positive number. So it's 4 to the power of 2 equal to 16. Next, I have 4th root of 1 over 16. I can simplify this in this form. 4, and then here, 16 is basically 2 to the power of 4. Now, I'm going to take the 4th root of top and 4th root of the bottom. 4th root of 1 is always just 1, and 4th root of 2 to the power of 4. These two cancel each other, and it will be just 1 over 2 left. Okay, next, I'm going to simplify these expressions. For the first one, I'm going to work on each of these parentheses that we have separately. R times S to the power of 3. So what I do here, I'm going to raise R to the power of 3 and S to the power of 3. Basically, this power will be distributed for these two terms that we have inside the parentheses. So this will be R to the 3 times S to the 3. Then the next parenthesis, 2 to the power of negative 2. So it's 2 to the power of negative 2 and S to the power of negative 2. Then 4 to the power of 4. Then R to the power of 4. next step, I need to combine the like terms. What are the like terms? Those are the ones that have the same base, like r to 3 and r to 4. That will be like this, r to 3 and r to 4. I'm going to combine these two together. And then I have s to the 3 and s to negative 2. So I'm going to write them together, s to 3 and s to negative 2. And then the last one are these numbers, 2 to negative 2 times 4 to the power of 4. Okay, r to 3, r to 4, keep the base and add up the exponents. It will be 7. Next one, again, keep the base because we have the same base with different exponents. They are multiplied together. So this will be exponent products. So keep the base and add up the powers. 3 and negative 2 will be equal to 1. And then here, 2 to the negative 2 and 4 to the 4. I can simplify this in this way. I'm going to write that here. 2 to negative 2 and 4 to 4. 4 is basically 2 to the power of 2. That is raised to the power of 4. So I can multiply the powers because this is power of power. So this will be 2 to negative 2 times 2 to the power of 8. 2 times 4 is 8. Now I'm going to keep the base and add up the exponents. Negative 2 and 8 will be 6. So this will be 2 to the power of 6. The best way to write such an expression is to write the numbers first as the coefficient, 2 to the 6, and then write the letters like r to 7 and s, because s to the power of 1 is just s. And that's the answer. Okay, next one. Here, the best thing is to find the like terms. 12 and 1 over 2. So I'm going to write them together, 12 and 1 over 2. And then we have x to the 2 and x to 5, x to 2 and x to 5. And we have y's, like this one and this one, y to 4, and y, basically, if I don't have anything on top, it's basically 1. Now I'm going to combine the like terms, 12 and 1 over 2. They can be simplified. 2 to the 2 divided by 2 is 1, and 12 divided by 2 is 6. So this is 6. And then keep the exponents, keep the base here as x. So I'm going to write it in this form, x, and add the exponents. 2 plus 5 is 7. For the next one, again, y, keep the base, and add the exponents. 4 plus 1 is 5. So this is just 6, x 7, y 5. Next one, I'm going to address the parentheses that I have here first. So this will be x squared to the power of 4, x squared to the power of 4 times y cubed to the power of 4. And then the next one will be x to the power of negative 3 times y to the 4 to the power of negative 3 over x squared times y. Now, x to the 2 to the 4. This is power of power, so multiply the powers. Keep the base. This will be x to the power of 8. Then this will be y to the power of 3 times 4, y to the 12. X to negative 3 is just x to negative 3. And y to the power of 4 times negative 3 is y to negative 12. Over x squared y. Now I'm going to combine the like terms. These two together, it will be x to the power of 8 minus 3. So just keep the base and add up the exponents. 8 and negative 3 is 5. And then the next one is y, keep the base and add up the powers, exponents. 12 and negative 2 will be 0. We know that anything to the power of 0 is just, anything to the power of 0 is equal to 1. X squared, y. Now, I have 1x to the 5 on top and x to the power of 2 in the bottom. So I can combine these two. It will be x to the power of 5 minus 2, which is x to the 3. And in the bottom, I had just a y, so I'm just going to keep that. So this will be the answer. Then I have something to the power of negative 1. So the first thing that I want to do is to get rid of this power of negative. So I'm going to flip the base. So 4b to the power of negative 1 over 3 will go to the top. And whatever I have on the top will go to the bottom, 3 to a to negative 2. Then the power will be 1. But since we know that if we have a power 1, it's just equal to the base, so basically I don't even have to write this. Okay, now I'm just going to simplify whatever I have here. 4 and 3, they don't have any negative power, so I'm just going to keep them, 4 and 3. But b has a negative power, so I need to get rid of the power of negative. I'm going to move that down. So this will be b to the power of 1 over 3. And this a, again, has negative power, so I flip it and move it to the top. And that's it. This will be my answer. I can't simplify this anymore unless I want to change this fraction power in the radical form. So this will be a 4a to 2, 3 third root of b. That's the answer. Okay, next is the graph of exponential function. Let's say we have y equal to a to the power of x, and a is any number greater than 0. We want to know how does the graph will look like. I have already used my calculator and added this to my calculator, 2 to the power of x. So I assume that in this case the base is equal to 2. Now I want to graph it. As you see, this is the general form of the exponential function. From one side, on the right side, it's going to continue forever. It's going to continue go to the top, and from the left side, it's just getting close to this line, which is y equal to 0 and doesn't pass. Let's just have a quick look at the table. As you see here, I'm going to move down first to 0. Okay, so as you see here, if x is 0, that means I have a to the power of 0. The base is 2 here, so x is 0. It will be like, let's consider this is my x and this is y, which is 2 to the power of x. If x is 0, y will be 1. How is this possible? Because it's 2 to the power of 0, which is equal to 1. So if x is 0, y is 1. But if x is 1, then y will be 2 to the power of 1, which is 2. So if x is 1, y will be 2 to the 1, which is 2. These are the most important points on an exponential function. We always consider these to graph the function. If I just consider the other numbers, as the x is going up, like it's increasing, the y is also increasing. But what happens to the y if x is decreasing? Like if x is a negative number like -1, it's 0.5. If it's -2, it's 0.25. -3 is 0.125. As you see, x is decreasing, y is also decreasing, but it's never getting close to, it's always getting close to 0, but it never passes 0. It's never going to be a negative number. That's why the graph is always looking like this. It's never going to be a negative number. It doesn't pass the y equal to 0. This means we have an asymptote here. So we're going to have an asymptote over here. I already have the line, so I'm going to move that here. This is the asymptote that I have. I'm going to call that y equal to 0. This is the asymptote that we have. So my graph always passes to 0 and 1, 0 and 1, and also 1 and 2. Let's say this is 1 and this is 2. So it's going to pass through these 2 points. From the right side, it's always increasing, going up, and from the left side, it's getting close to the asymptote, but never passes this line. So this will be the graph of an exponential function. And it doesn't matter what is my base, the general shape is always going to be like this. So let's change this function. Instead of 2, I'm going to write 9. Okay, so this is 9 to the power of x. As you see, again, the graph is going to look the same way, just with a little bit kind of stretch or compression. It's going to be the same thing. From the right side, always going up, and from the left side, getting close to y equal to 0, but never passes this line. Okay, so this is the general form of the graph. Let's find the domain. We know that domain is always about the x values. That means I need to move from left to right. So as I move from left to right, I see that the graph is covering all the x values. It's always defined for all the x values, and we don't have any limits here. So domain is -infinity to infinity. How about the range? Range is about the y value, so I move from bottom to top. As I move from bottom to top, I see that there's nothing defined for negative y's. It's going to start from all the positive values after 0. So it's going to start from 0 and goes to infinity, but the 0 itself is not included. So I'm going to put a parenthesis. Instead of bracket, I'm going to put a parenthesis here. So that will be the range of the function. Asymptote, as we just said, is y equal to 0. Do we have any x-intercept here? No. X-intercept is where the graph is meeting the x-axis, and there's nowhere here that the graph is meeting the x-axis. So we don't have any x-intercept. But do we have any y-intercept? Yes. The graph is meeting the y-axis at this point, which is 0 and 1. This is the y-intercept. So this is the general form of the graph. Always consider these two important points when you are trying to graph the function. Find 0 and 1, and the next point is 1 and the base. Whatever is the base, like here is a, let's just write this base so you don't get confused about this. So it's 1 and base. Whatever is the base is going to be here. Okay. Now let's talk about the transformations. Like all other functions, exponential functions also could be transformed, like moved up, down, left, right, stretched, or compressed, or reflected. So any of them could happen. How do we formalize that? This is a general formula for transformations on exponentials, like y equal to c times a to the power of x plus b plus a. So what does each of them do to your function? A determines the vertical shift. That means moves up or down. Let's say, for example, I have y equal to 2 to the power of x. minus 3. That means it's moving down 3. If I have y equal to, let's say, 5 to x plus 9, that means the graph of 5 to the x is moved up 9. This 5 to the x is the parent function, and it's going to be moved up 9. Here, 2 to the x is the parent function, and it's moved down 3. Then horizontal shift is happened when we have the b value. Something is added or subtracted to x that is moving to left or right. For example, y equal to 2 to the x plus 3. This means we are moving left 3. If I have y equal to 2 to the power of x minus 3, that means we are moving right 3. C determines vertical stretch or compression. Like if I have, let's say, y equal to 5 times 2 to the power of x, that means this graph is vertically stretched by the factor of 5. Or if I have y equal to 1 over 5 times 2 to the x, then this is compressed by factor of 1 over 5. Reflection over x-axis happens when you have the c value as a negative number, like if you have a negative number before a. For example, I have y equal to negative 2 to the x. This will be reflected over x-axis. Let's do some examples here. We have y equal to 2 to the power of x minus 1 plus 3. The parent function here is y equal to 2 to the x. First of all, I'm going to graph 2 to the x. So I'm going to consider the two important points. One of them, if you remember, was 0 and 1. And the other one was 1 and the base. Base is 2, so it will be 1 and 2. So the 2 points are 0 and 1 and 2 here. So I graph them. Then I'm going to graph the parent function. So this will be the parent function. From the right side going to infinity, from the left side gets close to the asymptote, which is y equal to 0. Now, what transformations do we see here? We have plus 3 here. This means move up 3. And minus 1 means we are moving right 1. So first of all, I'm going to start the transformation by moving the asymptote. Move it right 1. As you see, as I move this right 1, it doesn't make any change because this is just a straight line which is continuing forever. So as I move it to left and right, nothing will change. So that doesn't show anything, basically, doesn't change anything. Then move up 3. So I'm going to move this 1, 2, 3 up. So it will be here. So that's my asymptote. Then I'm going to move the 2 points. This point is going to be moved 1 right and 3 to the top. 1, 2, 3. So it's going to be here. And this one again, 1 to the right and 1, 2, 3 to the top. Now I'm ready to graph my function. So it's going to be something like this. So this will be the new graph. Next one, y equal to e to the power of x plus 1. First of all, keep in mind that if you have e is just called the Neperian number and it's equal to 2.7. So the base is basically 2.7. Because this is a famous number, we call that e. So if you see e, do not freak out, just 2.7. Okay, so first of all, I'm going to graph the parent function. That's e to the power of x. So the two important points are 0 and 1, and 1 and the base, which is 2.7. The points are here, 0 and 1, 1 and base 1, and 2.7 is going to be somewhere like this. The asymptote is here, and this will be the graph. Now, what transformation do we see here? X plus 1, that means we are moving left 1. So first of all, I move the asymptote. If I move this left 1, nothing will change. So the asymptote is going to remain where it was. And then the points that we have here are going to be moved left one. So this one will be here, and this one will be just moved left one over here. And this will be the graph of my function. I mean, basically it should pass this point. Let's graph it better. Pass this point. So it's going to be something like this. So this is how we graph these functions. Now you can use the quizzes that I have posted on your Google Classroom to do your homework. That was today's lesson. Have a good day.